All right, let's go ahead and start talking about unions of sets. So the union of two sets, A and B, is everything that's in A or in B or in both. Okay, and when we talk about unions, this or both here is sort of implied, so we don't really have to be explicit about that. We don't have to say that. It's just implied that we mean A or B or both. Okay, so how do we denote that? Well, a union is denoted like this. So the union of A and B is going to be A union B. Okay, so this isn't the letter U. It's different from the letter U. It's just sort of like this little cup thing. Okay, so it's really not the letter U. So just be careful of that. But anyway, A union B, it's denoted like this. And if we use set builder notation, so open curly brace here, and it's all X such that X is an element of A or X is an element of B. Okay, so we talked about this element notation. We talked about that in an earlier video, and we talked about set builder notation in an earlier video also. So if you want to check those videos out, if you're not familiar with these, please go ahead and do so. Anyway, A union B is defined to be the set of all X such that X is in A or X is in B. And remember, X could be in both. Okay, so this is not what's called an exclusive OR. Okay, so it's not either A or B and only one or the other. It could be in both, so X could be in both, that's fine. Okay, so that's the definition of a union. Let's talk about some properties, and then we'll see some examples too. So some properties here. So we have a few properties to list out. Okay, so properties. Property one says A union B equals B union A. Okay, so in other words, if you take the union of two sets, it doesn't matter what order you think about it. Okay, why is that true? Well, A union B is the set of all X such that X is in A or B. Well, what if we just swap A and B? Then here, we're going to swap A and B. Okay, so that's going to be A. Oops, this marker doesn't work anymore. Not really. So this is going to be B. That'll be A. Okay, and then we swap A and B over here too. Okay, so this will be B, and now this is A. Well, what's different? Absolutely nothing. Okay, it's the set of all X such that X is in B or X is in A. Okay, it's one or the other or both, right? It's in B or A or both. Okay, so absolutely nothing is different here. Okay, it looks different the way we write it, but it's still exactly the same thing. Okay, so whether you do A union B or B union A, it's all exactly the same thing. Okay, so here's A, B, and A and B. Okay. So property one just tells you that it doesn't matter what order you take unions in, you're just going to get the same thing. Okay, so property two, so we have 4 properties listed out. Property two says if you take the union of a set with itself, you just get that set back. Okay, so A union A is just A. Why is that? So let's come back up here and look at this. A union A, what's that going to be? Well, it's the set of all X such that X is in A or X is in A. Okay. Well, if X is in A or X is in A, then where's X? It's in A, right? So this is sort of just a redundant statement. So X is in A or X is in A. That really just means X is in A. Okay. So A union A is just the same thing as A. Okay. By the way, that's not really a formal proof. It's just sort of an informal explanation. So if you're looking for a formal proof, that's really not going to cut it. But it's just an informal explanation that, if you take a union of a set with itself, you're basically saying, give me all the elements that are either in A or both, but it's the same set twice, right? So of course, you're just going to get just the one set back. Okay, so nothing more, nothing less. You'll just get everything back that's there. Okay, so that's A union A. Let's reset this. Okay, so that's property two. Property three here says if you take the union of any set with the empty set, you're just going to get that first set back, okay, the set A. Okay, so any set union with the empty set just gives you A back. Why is that? Well, let's come back up here again and see. So if we erase this here, let's erase this. So A union the empty set is what? It's the set of all X such that X is in A or X is in the empty set. So we talked about the empty set in an earlier video if you want to check that out if you're not sure what that is. So A union the empty set, that's kind of bad right there, but anyway, A union the empty set is all x such that x is in A or x is in the empty set. Well, the empty set has no elements, right? It's empty, that's why it's called the empty set. It has no elements in there. So this right here gives us nothing. So all we have is really x in A. So this is just the same thing as the set A, okay? And again, that's not really a formal proof, just an informal explanation. Okay, so that's that. So again, A union the empty set is just going to give you back A because the empty set has no elements. Okay? And remember, a union is the set of all elements that's in one of these sets or both of them. Okay? Either one of them or both. So anyway, let's go ahead and reset this then. So that was B and B. Okay. Now the fourth property here. So that's our last one, that's our last property, then we'll talk about some examples. So the fourth property says A union B union C, like this, is the same thing as A union B union C. Okay, so property 4 basically says if you want to take the union of 3 sets, okay, you could take the union of the second and the third one, and then union with the first, or you could do the union of the first 2, and then union that with the third one. Okay, so in other words, it does not matter if you want to group them like this or like this, you're still going to get the exact same thing back. Okay, because when you union 3 sets, A union B union C, okay, all you're really saying is give me all the elements that are in A or in B or in C or any 2 of them or any 3 of them. Okay, so as long as the element appears in at least one of these sets, then it's going to be in the union. Okay. So really, that's kind of why that's true, is that when you take a union, you're really just saying, give me all the elements that appear in at least one of these sets. Okay, that's all you're really saying. Give me all the elements that are in at least one of these sets. So when you're looking for all the elements that are in at least one of these sets, it doesn't matter what order you look at them, right? So I can look at this one first, or one of these 2 first, whatever. So again, all you want is all the elements that are in at least one of these sets. So that's really what a union is. Give me all the x such that x is in at least one of these guys. Okay, it's in A or it's in B. It's in at least one of them, or it could be in both, right? And again, the union of 3 sets could be in any one of them, any 2 of them, or all 3 of them. Okay. So it might sound like a complicated concept, but it's really not that bad. So let's see some examples here. So we'll block off some space. So example 1, let's say we have A equals 2, 3, 5, and B equals 6, 7, 8. Okay, so then what's A union B? So remember, A union B is the set of all x such that x is in A or x is in B. Okay, so A union B is going to be everything that's in A and everything that's in B. That's all it is. That's all it's going to be. So what's in A? 2, 3, 5. 2, 3, 5. What's in B? 6, 7, 8. Okay. And that's really all there is to it. It does get a little more complicated than this, but this is probably one of the most simple types of examples we can have. But anyway, example 1 here. Here's a set A, 2, 3, 5. A set B, 6, 7, 8. And A union B is everything that's in A along with everything that's in B. Okay. What if we did B union A? So remember, B union A ought to be the same thing, right? So what if we thought about it as B union A? Well, then what would we have? We would have, so just to illustrate a point here, B union A. So we can think, okay, let's look at the set B first. Then we get 6, 7, 8. And if we look at A next, we get 2, 3, 5, right? Well, hey, it's exactly the same set, right? These 2 sets are exactly the same. Yeah, the elements are listed in a different order, but remember, that doesn't matter. Okay, so when you do the listing method for sets, the order that you list these guys in, it does not matter at all. Okay, so these 2 sets are exactly the same thing, because again, the order just doesn't matter. Okay, how about example 2? Let's take a look at this. And again, this just illustrates this first property here. A union B is the same thing as B union A. Okay. Okay. Example 2, let's say we have A equals 0, 1, 2, and B equals the set 2, 3, 4. Okay, so a slightly different situation. What's slightly different? Well, in example 1, A and B had completely different elements. Okay, 2, 3, 5, 6, 7, 8. They didn't have anything in common. Well, here, A and B have one element in common, right? A is 0, 1, 2, B is 2, 3, 4. How's that going to change our answer? Well, it's going to change our answer like this. So what's A union B? Okay, how's that going to change how we do things? Well, what's in A? 0, 1, and 2. What's in B? 2, 3, and 4, but we already listed 2, so we do not list it again. Okay, so it's actually a requirement that you only list it once. Okay, so if you say 2, 3, 4, that's actually wrong. You do want to be very careful about that. So since you already listed 2, do not list it again, only list it once. Okay, so A has 3 elements, B has 3 elements, but the union only has 5 elements, okay, because A and B have an element in common. Okay, so be very careful about that. A is 0, 1, 2, B is 2, 3, 4. A union B is the set 0, 1, 2, 3, 4, okay? Because this is the set of everything that's in A or in B or both. And again, yeah, 2 appears in both of these sets, but that doesn't matter, you still only list it once. And if you list it more than once, it really is wrong, it's something else, it's different. Be very careful about that, okay? Okay, so just an important point there is that if you have an element that appears in both sets, then just still only list it once. Okay, and the same thing is true if you're taking a union of 3 or 4 or 5 or 6 or 7 sets. Okay, if an element appears in more than one of them, you still list it once. Always just list it once. Always, always, always. Okay, so again, when you're doing a union, always list each element once. Okay, each element that appears. Okay, so that's example 2. Let's do, since we illustrated this property in the first example, let's maybe illustrate this property here. So what if we wanted to do A union A? We do A union A. Well, remember A union A, that's the set of everything that's in A or in A. What's in A? 0, 1, 2. What's in A? 0, 1, 2, but we already listed all of those. Okay, so we just get this in the union. Well, hey, what is this? 0, 1, 2. 0, 1, 2. It's exactly the same thing as the set A. Okay, so that illustrates property 2. Yeah, remember that's not like a proof for property 2, that just illustrates property 2 and how it works. How about property 3? That'll be a quick one. We might as well just illustrate that one real quick. What about A union the empty set? Well, that's everything that's in A. Okay, what's in A? 0, 1, 2. Union with everything in the empty set. What's in the empty set? Nothing, because the empty set is empty. Okay, it has no elements. Okay. So that's, we just get 0, 1, 2. Well, hey, what's 0, 1, 2? It's the same thing as A. Okay. Okay, so, and that illustrates property 3, that if we union any set with the empty set, we just get that first set back, okay? And actually, property 1 and property 3 together tell us that this is also the same thing as empty set union A, right? Because remember, it doesn't matter what order you take a union in, could be A union B, B union A, whatever, you get the same thing. Okay, so A union empty set is the same thing as empty set union A, and either way you just get back A, okay? And I'd like to point out, you know, we're calling these sets A and B. It doesn't matter what we call the sets, so these would be exactly the same thing, or exactly the same property would be true if we use B's instead of A. So in other words, B union B, B union, I'm kind of out of room here, but B union B is the same thing as just B, right? B union the empty set is the same thing as B. Okay, so yeah, we're using A's over here, and we're doing the examples with A's and things like that. But it does not matter. Okay, so these A's and B's over here, the A's and B's here just represent sets in general. Okay, when we talk about the A's and B's here on this side of the board, they're just representing any sets in general. Okay, any sets in general that we're talking about. But here we're using specific A and B to illustrate points, and here's specific A and B to illustrate points. Okay, so one more example that we'll use to illustrate the fourth property here. Okay, so let's make some room here. So now we're going to have 3 sets. So for example 3, let's say we have A equals 6, 7, 8. B equals 2, 4, 6, and 8. And C equals 2, 3, 5. Okay. Okay, so now let's illustrate that property 4 is true. Okay, so we're just going to illustrate an example of using property 4 here. So let's do A union B union C like this first. We'll do it like the left side first. So A union B union C, we're going to do that one first. Okay. So if we do that one first, what do we have to do? First we have to do B union C. Okay, so what's B union C? Remember the parentheses, do what's inside the parentheses first. So first we have to do B union C. Okay, so remember this is everything that's in B or C or both. What's in B? 2, 4, 6, and 8. What's in C? 2, 3, and 5. Okay, but be careful, we already listed 2, right? So we do not list it again. Okay, we do not list it again. But we did not list 3 and 5 yet. Okay, so that's B union C, 2, 4, 6, 8, 3, and 5. Okay, now what's A union that guy? Okay, so now we do A union B union C. So this just means everything that's in A or in B union C. Okay, what is B union C? It's this guy here. Okay, so if you wanted to, we can actually just call this set D, and this will be the same thing as A union D, and then it's a little easier to think about. Okay, we don't have to do that, but if you want to, if that helps you out, totally go ahead and do that. So just call this set one thing, call it D. Okay, so now we're going to call this set D, 2, 4, 6, 8, 3, 5. So A union B union C, now we're just going to call this set D. So this is the same thing as A union D. So it's everything that's in A or D, okay? So what's in A? 6, 7, 8. 6, 7, 8. What's in this set D? 2, 4, 6, 8, 3, 5. Okay, so 2, 4, we already listed 6, okay? We already listed 6, so don't list it again. What's next? 8 is next. We already listed 8, don't list it again. Okay, remember, you have to list it only once, or never list it more than once. What's next? 3 and 5. Did we list 3 or 5 yet? No, so let's go ahead and write those. Okay, 3 and 5. Okay, so that's A union, the quantity B union C like that, okay? So what if we wanted to do it the other way? Okay, so this kind of out of room here, so let's write this up here. So A union B union C like this turned out to be 6, 7, 8, 2, 4, 3, 5. Okay. And yeah, it is sort of custom to write them in increasing order, so it's more common to maybe say 2, 3, 4, 5, 6, 7, 8. But again, it doesn't matter, right? It does not matter the order in which we write these in, okay, which we write. So we don't have to worry about that. Anyway. So that's A union B union C. Now what about A union B union C like this? Okay. So again, we're just illustrating this fourth property here. A union B union C like this, well, how's that going to be? So first we do A union B. And remember, that's everything in A or in B, so what's that? Well, what's in A? 6, 7, 8. What's in B? 2, 4, 6, 8. Okay, so we do 2, 4. Now we already have 6. Okay, we already listed 6, and we already listed 8. So that's it. That's it for A union B. Okay. So now we have to union that guy with C. So now A union B union with C equals. So again, if we want, we can call this set D. Okay, call it D. So don't use C because C's already taken, right? So we have to say we'll call it D. So this will be the same thing as D union C. Okay. So if you know if you don't like looking at something like that, you can just say, okay, well this set A union B, I know what it is now. It's these elements here. So let me just call it D. So then A union B union with C. Well, since I'm calling this D now, I'm just going to say D union C. Okay. So what's D union C? It's everything in D or C, or both. What's in D? 6, 7, 8, 2, 4. Okay. So we're going to start with that. 6, 7, 8, 2, 4. Okay. And again, if you don't like that about calling it D, calling it something else, if you don't want to do that, there's absolutely no reason that you have to. You can just still say A union B. It's going to be exactly the same thing. Okay, I'm just going through this step here because maybe it's more familiar, easier to look at, easier to understand, because you only have one union to look at now, and not this second one here. Even though this union, we're done with this union, right? A union B, we've done that up here. We don't need that anymore. So if we want, we can just call that something simpler. Okay. So anyway, 6, 7, 8, 2, 4. That's D. Now what do we get from C? From C we get 2, 3, 5. Okay, so 2, 3, 5. Well, we already wrote down 2, we already listed that, so do not do it again. Okay, so only 3 and 5. Okay. And that's our A union B union C like this, 6, 7, 8, 2, 4, 3, 5. Okay. So let's go ahead and come up here, and what do we get? We get 6, 7, 8, 2, 4, 3, 5. Okay. Well, hey, notice that's exactly the same thing as this, right? And even in the same order, that's nice. So A union B union C, 6, 7, 8, 2, 4, 3, 5. A union B union C like this, 6, 7, 8, 2, 4, 3, 5. Okay. So that's how you do a union of 3 sets. If you wanted to, you could do it all at once also. This just sort of, I just wanted to illustrate this fourth property here, that if you take a union of 3 sets, you can look at 2 of them at a time and it doesn't matter. And by the way, also, since A union B is the same thing as B union A, you could switch the order in here too. So you could say A union C union B, okay, is the same thing as A union C union B, like that. Or you could switch B and A in here. So really, if you take unions of sets, the order that you look at them does not matter at all. Okay, you can swap them however you want. You can group 2 at a time however you want. So that's a really nice thing about unions, is that if you have to union a bunch of sets, if you have to take the union of a bunch of sets, you can just do it in whatever order you want. Okay, you can look at any 2 of them at a time, any 3 of them at a time, whatever you want to do. Okay. So that's example 3. If we look at them 2 at a time, okay. What if we don't want to look at them 2 at a time? What if we want to look at all 3 at once? We can do that, right? Let's just do that, and then that'll be it for this video. So let's see. So what if we just wanted to do A union B union C, okay, without looking at, with just looking at all of them at once, not 2 at a time. So what's in A? 6, 7, 8. Okay, we get 6, 7, 8. What do we get from B? 2, 4, 6, and 8. Okay, 2, 4, 6, and 8. So 2, 4. But we already have 6, we already have 8, so do not write them again. Okay. Now what do we get from C? 2, 3, and 5. We already have 2. Okay, we already have 2. Do not write it again, but we still need 3 and 5. Okay. Well, hey, look. 6, 7, 8, 2, 4, 3, 5. 6, 7, 8, 2, 4, 3, 5. 6, 7, 8, 2, 4, 3, 5. Okay, so we get exactly the same thing. Okay, so you can group 2 of them at a time together, like this or like this, and I'm not going to go through it, but you can do C union B, B union A, you can switch them around. You might get a different order, but remember the order that we list them in with the listing method does not matter, okay? The order does not matter. All that matters is that the elements are all the same, and the order that we write them in does not matter. Okay, so you can do any 2 at a time like this, or you could just look at all 3 sets at once, and you'll still get the same thing when you do a union. Okay, so that's all about unions, so the definition, some properties, and a few examples.